just now we started RLC circuit. In that, you see the figure, we are running RLC. They are in series. The voltage across R is VR, across L is VL, across C is VC. और हमने अप्लाई किया EV, AC अप्लाई किया. EV is your RMS value, RMS voltage of the AC supply. Circuit current IV, that is your RMS current. ठीक है, यहाँ तक क्लियर है. अब मुझे करना क्या है, VR, VL एंड VC के बारे में लिखना होगा. क्या लिखे? VR, VL एंड VC. तो अभी तक जो आपसे बात की उसके हिसाब से बताओ क्या लिखेंगे. VL, VR, VL एंड VC क्या लिखना चाहिए मुझे? कौन बताएगा? Who will tell?
हाँ
सर VR is equal to IV into R.
या ठीक है. यस ठीक है, आगे बढ़ो. VR is equal to
VL
IV into R. करेक्ट है, बिकॉज करंट उसके थ्रू फ्लो कर रहा है, वो क्या है? IV है, और रेजिस्टेंस R है, तो सिंपल ओम्स लॉ यही बोलता है. So you are right, 100% right. Your VR is IV into R. ठीक है. VL क्या होगा?
और IV is XL.
into L.
Yeah, ईशान, tell me. IV into
L.
L नहीं होता, L तो इंडक्टर होता है.
XL.
XL रिएक्टेंस लेना होगा ना. Are you
Yes, sir.
getting? So
Yes, yes, sir.
XL. Now VC क्या होगा ईशान? You tell me.
IV into XC.
Yes, very good. It cannot be IV into C. It will be IV into XC. अब आते हैं इसका फेज के बारे में बात करेंगे. IV इंडिविजुअली वोल्टेज अक्रॉस R, L एंड C. IV तो क्रॉस कर रहा है, तीनों से जा रहा है. ठीक है. तो IV का रिलेशन VR के साथ, जब हम VR की बात कर रहे हैं, क्या होना चाहिए? फेज रिलेशन. IV, यस, who will tell? IV is in phase. लिखना पड़ेगा ना. IV is in phase with your, कौन सा है? VR. ठीक है. Similarly, who will tell me? अभी आ गया आपका VL, इंडक्टर. सो ओनली इंडक्टर के केस में क्या होता था, वही लिखना होगा. IV और VL के बीच का फिल इन द ब्लैंक्स कर, फिल इन द ब्लैंक कंप्लीट करो आप. IV या तो लैग करेगा या लीड करेगा, और कितना से करेगा भाई? सो IV
Yes.
VL को लैग करेगा या लीड करेगा? देखो, हमने आपको बताया था एक तरीका इसको याद रखने के लिए. क्या तरीका बताया था, बताइए. हमने बताया था L फॉर लैग, रिमेम्बर. अदर वन इज कैपेसिटर. तो एक लैग है तो दूसरा लीड करेगा. तो ऑलवेज रिमेम्बर L फॉर लैग. तो अगर L के अगेंस्ट वोल्टेज देख रहे हैं, L के क्रॉस वोल्टेज देख रहे हैं, तो मुझे करंट और वोल्टेज का रिलेशन में, फेज रिलेशन में लिखना होगा IV lags. L for lags. So lags VL by how much? Pi by 2. ये तो पता ही होगा. तो यहाँ पे क्या लिखना चाहिए मुझे? यस, IV VC by pi by 2 ही होना है. यहाँ पर क्या होगा?
Lead.
लैग
Leads.
हमारा, यस, लैग हो गया L के लिए, तो C के लिए लीड बज रहा है, तो लीड्स VC.
So once
ये
can you
हमें,
like explain like how to see whether it's lags or leads or is it in the phase?
ओनली, I'll tell you, because only इंडक्टर के केस में हमने क्या देखा था? ओनली इंडक्टर, इन दैट केस व्हाट वी हैड सीन दैट योर IV lags voltage, current lags voltage by pi by 2, right? That's why. And how we have got it? We have got it by the simple equation, like here in place of AC supply EV we had written here. हम क्या लिखते थे वहां पर? We used to write E naught sin omega t. और जब I निकालते थे instant, this is your instantaneous value, E naught sin omega t at any instant. EV is your RMS value of this E naught sin omega t. तो अब ये है कि यहाँ पर जब हम आई निकालते थे तो क्या निकलता था हमारा, आई नॉट साइन ओमेगा टी माइनस पाई बाई टू. यस, गॉट इट. So
Yes, sir.
minus pi by 2 used to tell that, okay, there is a lag, current is lagging. And wave diagram से भी देखा था आपने, if you refer that those area. So इसमें क्या हो गया, इसलिए हम कहते हैं कि IV lags VL by pi by 2 here. Correct? Got it now? Similarly for capacitor, only capacitor, we had seen that your I current is your I naught sine omega t plus pi by 2. That is what we used to, we have seen earlier, right? So इसमें क्या हो गया कि I अगर प्लस है, प्लस pi by 2 है, इसका मतलब बड़ा क्लियर है कि IV leads your VC by pi by 2. Individually देख रहे हैं. We are just trying to understand individually, and then combined effect we'll see. So these three results are going to help you to draw the phasor diagram, correct? And then we'll see later on the wave diagram. तो चलो phasor diagram draw करते हैं. X axis के along क्या लेना है? Who will tell?
IV.
Yes,
I.
IV रिजर्व. IV के लिए रिजर्व रखा है. अब उसके हिसाब से हम देखेंगे हमारा VL किधर होना चाहिए और VC किधर होना चाहिए. सो एंड VR भी देखेंगे. सो VR क्या होना चाहिए? We are saying that IV is in phase with VR, right? IV is in phase with VR, means दोनों एक ही लाइन में होना चाहिए, तभी तो फेज में रहेगा ना. तो हम क्या करेंगे? We'll be taking now for the VR, which has to be along the same line somewhere like this. We are taking, this is my VR. Clear? The
Yes,
brown
sir.
one, this brown one, that is VR, and the white one, that is IV. They are in phase. There is no phase difference between them. उसके बीच में कोई एंगल तो है नहीं. So phi is 0. Is in phase mean your phi is 0 in that case. Clear? Phase difference is. So now we come to the second one. IV lags VL by pi by 2. So where we should place my VL? Of course, VL और VC को होना है y axis पर. तो ऊपर की तरफ कौन जाएगा और नीचे की तरफ कौन जाएगा? By seeing this IV lags VL by pi by 2, we can understand. IV कहाँ है? IV तो x axis के along रहना ही रहना है. तो हमारा VL ऊपर की ओर होने से IV lags VL by pi by 2, या नीचे होने से होगा, यही देखना है. Yes, any one of you? Any one of you? Should I help?
Yes, sir.
Okay. अगर मैं VL को ऊपर रखता हूं तो let us check what happens. VL is here. अब IV और VL के बीच में pi by 2 है, एंड IV क्या हो रहा है? लैग्स. देखो क्या होता है फेजर में, all the phasor will move anti-clockwise with omega. Whatever phasor we are taking, your IV is phasor, VR is phasor, VL is phasor, all are moving on the same, right, with the center at O. I can say they are moving with the same omega in anti-clockwise. तो जब ये मूव कर रहा है ना, तो VL क्या है? IV के हमेशा आगे आगे चलेगा, या हम बोल सकते हैं IV क्या है? VL के हमेशा पीछे पीछे चलेगा. आगे तो VL ही रहेगा ना. IV तो पीछे रहेगा इस जर्नी में. एंटी क्लॉकवाइज दोनों को साथ में रोटेट करना शुरू करो तो ये होने वाला है ना. सपोज हमने लिया ये हमारा VL है और ये हमारा IV है, ठीक है. अब दोनों यही ऐसे ही रखा है ना, अब दोनों साथ साथ मूव कर रहे हैं. तो क्या है, ये रेड वाला तो हमेशा आगे ही रहेगा. रेड वाला पेन तो हमेशा आगे रहने वाला है ब्लैक वाले पेन से. रेड वाला पेन क्या है? VL है. और ये क्या है? आपका IV है. तो हमेशा आगे रहने वाला है, 90 डिग्री मेंटेन रखेगा. इसीलिए VL को ऊपर होना है, तभी आपका कह सकते हैं IV lags VL by pi by 2. Yes or no? Got it?
Yes, yes, sir.
Similarly, the third point you come, IV leads VC by pi by 2. ये तो समझ में आ रहा होगा. क्या होना चाहिए बता दो ईशान. Yeah. IV
IV
leads
is
VC
leading
by,
VC by pi by 2.
Yeah, so whether VC will be upward or downward,
It's leading, so it should be upwards.
it should be upward. Which one is leading?
IV.
IV.
IV is
IV is
leading VC.
leading VC. So IV को तो आगे रहना है ना हमेशा इस रोटेशन में.
Hmm.
तो कब होगा ये? अगर मैं VC को नीचे की तरफ रखता हूँ तो ही होगा ना. चेक करो. फिर से
हाँ.
दोनों पेन लेता हूं मैं. इस समय इस रेड को VC के डायरेक्शन में रखता हूँ. ठीक है, VC हमारा नीचे की ओर है. चेक करो. ठीक है, और ये तो रिजर्व है IV के लिए. रेड वाला ये मेन पेन हमारा जिससे मैं लिखता हूँ वो रिजर्व है. अब दोनों साथ साथ रोटेट होना है. वंस दे आर रोटेटिंग एक साथ क्या होगा? IV हमेशा आगे रहेगा. यस और नो? बिकॉज रोटेशन एंटी क्लॉकवाइज ही होना है. एम आई राइट? IV
Yes, sir.
हमेशा लीड करेगा VC को. सो थर्ड केस IV लीड्स VC is satisfied. So all the phasor we have drawn IV, VR, VL, VC. So हमारा phasor diagram तैयार हो गया. ठीक है.
Yes.
अब इस phasor diagram को further complete करते हैं. Your EV क्या होगा? VR, VL and VC का एडिशन है. बट ये algebraic sum नहीं है. VR, VL and VC को simply we cannot say EV is equal to VR plus VL plus VC. We cannot say like this. Why? This is a phasor. So its characteristics is same as that of the vector. So vector addition जैसे करते हैं वैसे ही करना होगा. तो
Hmm.
सबसे पहले तो देख लो y एक्सिस में क्या है. VL अपवर्ड, VC डाउनवर्ड. तो ये दोनों का पहले निकाल लो वेक्टर. नेट वेक्टर क्या होगा? नेट दोनों का नेट phasor क्या होगा? VL is greater than VC here. Purposely we have drawn. It can be other way out also. So what will be the value? VL minus VC. वेक्टर क्या होता है? हमें क्या करना पड़ेगा? O2 VL back pink one will take it, and then this gray one will have to come down by that much of magnitude. जितना VC का है उतना ही आपको नीचे आना पड़ेगा. ये फाइनल पॉइंट हो गया. So O to this point, we are going to have O to this point. Say I'm taking this one as a brown one now. This will be your what? VL minus VC, right? This will be your VL minus VC. Yes or no? Yes.
Yes, sir.
Clear? ये VL को ऊपर ले लेता हूँ so that आपको confusion ना हो. So pink one is your VL. I have taken here. Clear? So VL minus VC. अब हमारे पास VL और VC दो थे, उसके जगह पर एक ही है VL minus VC. सही बात है ना? ठीक है.
Yes.
VL minus VC और दूसरा क्या बच गया? VR तो है ही है. अब ये दो फेजर रह गए, यानी कि दो वेक्टर रह गए. कौन कौन? VL minus VC which is upward from O, and towards the right we are having VR. इसका मुझे रिजल्टेंट देखना है, इसका मुझे सम देखना है. कैसे निकालेंगे? वेक्टर में क्या करते हैं? We just complete this rectangle and then this diagonal will make it the resultant of these two. I mean addition of these two. So हो क्या गया? ये addition of these two is nothing but the applied voltage EV. Check करना. Applied voltage EV is now I can say VR plus VL plus VC in the vector term, in the phasor term, isn't it? Here EV, now we got it. What is that? VL minus VC. So इस side में हम vector can be shifted anywhere as long as you are maintaining the magnitude and directions. So this fellow I can write VL minus VC. Yes or no?
Yes.
From here
Yes,
to
sir.
here, right? So right angle triangle बन गया. एक चीज ये देख रहे हैं. दूसरा ये देख रहे हैं कि EV और IV में रिलेशन देखो आप. फेज रिलेशन क्या होगा? IV lags EV by how much? By this angle. This angle is your mind it phi. Clear है? This angle is your phi. So phi is the angle between your EV and IV in such a way. देखो everyone has to rotate anti-clockwise. सही है ना? So everyone is rotating anti-clockwise. So you have to always see that IV will be behind EV in this rotation. EV तो आगे आगे चलेगा, पीछे पीछे चलेगा IV. ठीक है, IV will be always behind AV by how much? 5 in this rotation. Okay, so here we are getting your phi is, we can write here phi, this is your phase angle between EV and IV, right? Phase angle between IV
EV and
and
IV.
right. Clear दिख रहा है यहाँ तक? So what we can say now? We can say, we can conclude that your IV lags EV by kitna? 5. Can we say like this? Check it. Yes. Clear hai? So if I am telling my IV lags EV by 5, it says something, anything lagging, current is lagging voltage. Okay, we are having inductor, we are having capacitor, but thing is that ultimately हम ये देख रहे हैं कि मेरा current जो है, circuit current जो है, which is IV, is lagging the supply voltage, that is your EV, because हम RMS में ही बात करते हैं इसी में. So IV lags EV by 5. Lagging कहाँ होता है? Lagging कहाँ होता है? जहाँ L होता है, जहाँ L होता है. इसीलिए इस सर्किट को हम बोलेंगे इंडक्टिव सर्किट है. ठीक है, इसका नाम देंगे इंडक्टिव सर्किट. ओके, वी आर हैविंग कैपेसिटर आल्सो, इंडक्टर आल्सो, बट दिस फेलो VL इज ग्रेटर देन VC इज मेकिंग दिस, राइट? अदरवाइज क्या होता, VC बड़ा होता तो EV जो ऊपर की ओर गया वो नीचे की ओर आ जाता, वो भी देखेंगे. ठीक है, सो यहाँ पर वी कैन कंक्लूड दैट सर्किट current is lagging the supply voltage by 5. Since it is lagging, so circuit is CKT, I am writing in short, circuit is inductive. Got it? Circuit is inductive.
Inductive.
Yes, got it? Why it is inductive? Clear up to that?
Yes, sir.
Circuit is inductive, right? So this is another important thing we concluded, that your circuit is inductive. We are having capacitor, everything, but yes. अब आते हैं wave diagram. Omega t along the x-axis means theta. Omega t is the angle, and this side we are having both E and I, instantaneous value of the current, and I will be seen, right? So yeah, circuit is inductive. IV lags EV by 5. If I try to write the instantaneous value of I, how will be writing? That also let us see here. How will be writing that? I can write your current I must be equal to I naught into sine omega t. What is that? It is lagging. So minus 5. As minus 5. So it's lagging. It is coming later on. So fine, come back to the wave diagram now and try to draw with this help. कैसे करेंगे? E always we start from the origin, right? E always start from the origin. Start it. Take it E. Right? I कहाँ से start होगा? जहां से E ने start किया ना उसको behind रहना है, बाद में आना है. ठीक है, कितना बाद में आना है? फाई एंगल से आना है. फाई एंगल क्या है? 0 और 90 के बीच में है. 90 कहाँ है? This is the point we are having 90 degree. Yes or no? This is the
Yes,
point
sir.
we are having pi by 2 angle in terms of the angle. So इस दोनों के बीच में कहीं पर होगा. Say it is here. This angle is your how much? This angle we can say this is your phi. And so my current wave diagram will start after this phi. It is behind, right? It will be behind. So yes, we can draw this separately. Everywhere it will be after, right? So it will be after means current, see that voltage is going down here. the current will go down here somewhere after 5. This fellow is going up, white one is going up, this brown one now will draw, this will go up after 5. So everywhere after, because it is behind. बाद में आ रहा है. तो अब इस दोनों के बीच में 2 पॉइंट मिला, उसके बीच का कहीं ले लो, and then you make that. Okay, ये हो गया आपका current के लिए instantaneous value of the current, and white one is instantaneous value of your E, right? This is your instantaneous value of E. Clear है यहाँ तक?
Yes,
Okay.
sir.
Okay. Now, how to find the phi? How to find the tan phi or cos phi? We can do it easily again. This right angle triangle you come. I'll draw it separately. From there, we can get the value of phi. Phi will be always lag. So once you calculate the phi in numerical or anywhere, you must write in bracket lag or lagging, right? Then only your answer is complete, otherwise not. So we'll try to understand what could be my phi here. Yes, I can write my tan phi is equal to, tell me, VL. Phi के सामने क्या है, opposite क्या है, VL minus VC. So VL minus VC divided by base क्या है हमारा, adjacent क्या है, VR. So I'll be writing VR. Now VL, just now we had seen, it is IV into XL, VC, IV into XC, VR, IV into R. So well, I can write in terms of IV into VL. VL will be IV into XL. So सभी जगह से IV निकल आएगा बाहर, कॉमन बाहर निकालोगे तो न्यूमरेटर एंड डिनोमिनेटर में दोनों जगह IV निकल जाएगा, रह क्या जाएगा, XL here minus XC here divided by, yes, divided by R only. Yes or no? Yes. And if I
Yes.
try to get what is my power factor, that is your cos phi. Yes, cos phi is base by hypotenuse. So base is what? VR. Hypotenuse is what? EV.
E.
Right? EV क्या होगा in terms of IV? It will be IV into Z. Z is the impedance of this RLC series circuit. Right? Z is the impedance of the RLC series circuit. And VR क्या होगा? IV into R. So it will be R by Z. Yes or no? So this is your power factor, isn't it? We can write them R by Z, or here this side XL minus XC by R from the impedance triangle also, right? How come? Impedance triangle, are you aware of this? The last class we had. Do you remember how we can make the impedance triangle out of this? Yeah. So let us do here impedance triangle out of them. What was we had? Here we had your EV, right? Here we had your EV. Here we had your, this was your VR, and this was your VL minus VC. Correct? This was the thing. So here this can be written as I into Z. EV is I into Z. Z is the impedance of series RLC circuit, right? And here it will be your, this fellow I can write IV we should write. So IV into VL is your XL, VC is your XC. So IV into XL is your VL, and IV into XC is your VC. So we can write like this. And VR, what we can write? VR is equal to IV into R. Now, तीनों जगह से hypotenuse, perpendicular and base, IV and IV common निकाल दो, then it is your impedance triangle. Am I right? Then it will be your
Yes,
impedance
yes,
triangle.
sir.
So what we can write here? In that case, impedance यहाँ से अगर बनाना है मुझे तो क्या बनेगा? You will have your, this fellow will become Z. Z रह जाएगा ना, IV निकल गया तो Z रह जाएगा इधर Z. परपेंडिकुलर में क्या रह जाएगा, IV निकल गया तो XL माइनस XC, और बेस में क्या रह गया, IV निकल गया तो R only.
R.
Mind it, this angle is phi. Here also this will be phi only. There is no changes in that, right? There is no change in that. Very clear? So, well, I can write here. That's why we are able to write cos phi is equal to, straight away from impedance triangle, we can have R by Z adjacent by hypotenuse. And if I want to write for tan phi, yes, it will be R in front of phi, opposite to phi, we are having XL minus XC. So this is your opposite by adjacent. Adjacent is your R. So straight away I can write, right? Up to that is clear, I hope. Now come to that,
Yes,
how we
yes.
can find the IV out of this, right? Out of these three we had VR, VL and VC, right? I want to write what is my EV, right? So EV is your, or EV is your addition of VR plus VL plus VC in terms of the vector, in terms of the phasor. So yes, it will be, how we can write them? EV will be right angle triangle, you take it. Here we have drawn EV, VR, and then your VL minus VC, right? So you can take this right angle triangle. It will be a square root. This is EV becomes hypotenuse. So a square root of your, we can write VR square plus VL minus VC whole square. Can we write? I have written base square plus perpendicular square. Yes, it is. Hypotenuse is square root of that. So VR, I can write IV square R square, and plus here I can write IV into XL for your VL and IV into XC for your VC whole square root. Correct? Got it? So further, if I go, IV square will come out of the second term also, and I can take it out of the square root, then it will be R IV into a square root of R square plus XL minus XC whole square, isn't it? We can write like
Yes.
this. Clear है
Yes,
यहाँ
sir.
तक? So
हाँ, sir.
हमारा IV क्या हो गया? EV by this fellow, right? IV, you can write EV by, therefore your IV will be EV by this fellow R square plus XL minus XC whole square root, which can be written as Z. So I'll write EV by Z, right? Where your Z is the impedance, where your Z is called impedance of RLC circuit, series circuit, correct? Clear? And Z क्या होना चाहिए? What should be your Z here? Yes, Z will be equal to R square plus XL minus XC whole square root. Correct? This is what we'll be getting as Z in series RLC circuit. That is your impedance of the circuit. So now we'll think of if XC is greater than XL. I mean to say that VC is greater than VL, right? तो हमारा फेजर डायग्राम में क्या चेंजेस आएंगे? ये तो रिजर्व है IV के लिए, और इसी पे हमारा क्या रहना है VR, बिकॉज बोथ आर इन फेज. ठीक है, अब रह गया बात VL एंड VC का. तो VL को ऊपर होना है, तो हमारा ये VL है, और VC जो है वो नीचे की ओर होना है. ये हमने डिस्कस किया था. केवल हमने ये चेंजेस लाया कि VC हमारा बड़ा है VL से, तो फेजर डायग्राम कुछ ऐसा बनेगा. नाउ VC बड़ा है VL से, तो क्या होगा? VC आप नीचे की ओर आओ, फिर वापस VL का जितना मैग्नीट्यूड है उतना वापस ऊपर आना पड़ेगा आपको. तो समवेयर यू विल गेट द पॉइंट से here like this, right? Same magnitude. So finally, I am going to have, this is my VC minus VL. VC जितना बड़ा है उसमें से VL हटा दो तो VC minus VL. ओके, अब आगे क्या करना पड़ेगा? रेक्टेंगल बनाएंगे और जो डायगोनल है इसका वो हमारा क्या बन गया? EV. यस और नो? तो यहाँ पर फेज एंगल क्या हो गया? फेज एंगल नीचे आ गया फोर्थ क्वाड्रेंट में. ठीक है, अब यहाँ पर क्या हो रहा है? IV लीड्स EV, right? We'll write not V, we'll write EV. IV and EV के बीच में अगर हम देखें तो IV leads EV by 5. तो ये IV leads EV by 5. Okay, so हम क्या लिख सकते हैं? Your अगर इंस्टेंटेनियस वैल्यू ऑफ द करंट लिखना है तो क्या लिख सकते हैं? दो बातें होंगी, एक तो इक्वेशन क्या होगा और दूसरा सर्किट क्या होगा. तो IV लीड्स EV बाय 5. करंट कब लीड करता है वोल्टेज को? अगर सर्किट कैपेसिटिव हो तो, राइट? कैपेसिटिव हो तो यहाँ पर क्या होगा? दैट सेज क्लियरली दैट माय सर्किट इज capacitive. I'll write that, understand that circuit is capacitive because we know in case of capacitance only the current leads voltage, right? That's why circuit is capacitive here, right? Is it clear? And not only that, we can very much write the equation as well for your current. E to वही रहना है, E not sin omega t, but I will be I not sin omega t. This time circuit is capacitive, this time current leads voltage, so leads says that I must take plus here plus 5. Got it? And यहाँ पे अगर मुझे wave diagram draw करना है so both E and I here, right? And क्या हो जाएगा? E को तो हमेशा 0 से स्टार्ट होना है. अब हमारा I कहाँ पे स्टार्ट होगा? देखो I क्या है? लीड्स EV. I करंट लीड्स वोल्टेज. सो कितना से लीड? मतलब जहां ये देखो स्टार्ट यहाँ पर हो रहा है आपका, ये क्या है? E है. तो I कहां से स्टार्ट होना है? It is leading. Leading means ahead of it, correct? So it will be ahead means somewhere here this side with how much? This is your 5, right? It will start earlier. So your I will be starting here and everywhere it will be earlier. This fellow is going down. You check it here while crossing x-axis, I mean omega t axis, it is going down. Now I fellow will go down 5 angle before, right? So this way I can make my everywhere here also before, right? So this will be like this. This is your I. This way I can draw the wave diagram easily. Clear hai yahan tak? So now we'll just try to conclude all these things, what we have discussed, right? So in conclusion, if your VL is greater than VC, that is same as your XL is greater than XC. We had seen that your circuit is, tell me, VL is greater than VC, XL is greater than XC, circuit will be, yes, inductive or capacitive? Tell me, I'm asking you. Circuit is?
Inductive.
Inductor.
Yes. Yeah, circuit is inductive. Right? So phi will be, now further if I want to write about the phi phase angle, what we can write? Phi is leading or lagging? Tell me, phi lag or lead? Inductive means L,
So
L
leads.
means
L.
no, lag.
Lag, sir.
Yeah, L for lag, L for inductor. Remember that way. So again and again telling you. So this is lagging here. So whatever phi you will calculate, it will be lagging. How to calculate, we have written above. Now if you go to the next case, that if your VC is greater than VL, other way out, that is your XC will be greater than XL. Your circuit is this time, yes, capacitive. And in case of capacitance, what happens? Phi leading or lagging? In case of
Leading.
capacitive is leading, right? Lagging, you keep it reserved for L for lagging, right? Inductor. So other one will be leading. So phi here, leading. So once you calculate, you must write lead or leading in your answer. Got it? Clear? Now,
Yes.
one more case we'll take it. That is very interesting, right? And that is your, if I take it, your VL is equal to VC, then what will happen? Can you think? If VL is equal to VC, how the phasor diagram will look like? What will be your EV? What will be your Z? All those kind of things. Yes? Can you make it out? The third case, which is very, very important and very interesting, that if your VL is equal to VC, I mean to say your XL is equal to XC, what will happen? Your circuit is what we should write? Capacitive, inductive, or what?
So resistive.
Is a resistive, because the X component will go away. X component will go away. If this is the case, your Z is what? RS square. Remember RS square plus? Tell me. What was that? RS square plus
X.
XL
L plus
minus
XC whole
XC
square.
whole square, right? So this is your RS square, XL minus XC whole square root. If this is the case, XL is equal to XC, second term will be 0. So I'll be getting my Z is equal to R, you see. Your impedance of RLC series circuit will become R. So circuit will be now resistive. There is inductor, there is capacitor, but it's still circuit will be pure resistive. It will behave as a resistive. So whatever happens in case of only resistance, same thing will happen. I mean the IV and EV will be in the same phase. Phi will be 0, correct? So circuit is resistive. It means that if I am talking about phi, it is 0, correct? Phi is 0, no question of leading and lagging. Why it is happening? Quickly we'll discuss here. IV phasor diagram we are coming. You see what is there? IV along the x-axis. VR has to be along the x-axis only because VR is very much in phase with the, yeah, VR is very much in the phase with the IV. So I'll be taking here, this is my VR. Now, suppose if I take it, my VL and VC, this is your VL, and this side it will be VC, such that both are equal. VL is equal to VC. So if I try to add VL minus VC or VC minus VL, it will be, you will be at origin only, yes or no? Will be at origin only. So you are left with only VR. So your EV is equal to VR. In this case, you will find that your EV is nothing but VR only. Very interesting, correct? The last one gives rise to resonance. That kind of circuit where XL is equal to XC is known as resonance. That we'll be seeing in the next class, right?